So in our code, we're going to have two main classes. One of them is going to be this main linked list class that we're going to put all our methods in, all the ones that we reviewed a few moments ago. And then we're also going to have a node class, and this is going to represent each one of those nodes that we're actually doing operations on in our linked list. So let's first create the node class. That's very simple. It only requires 4 lines of code. So we'll say class node, and inside here, we'll just create an initialization function. We'll say def init self, and then we'll add a value to that. So we'll say val, and we'll say self.val is equal to val. And then we also need a pointer to the next node, if there's going to be a next node. There may or may not be a next node. So we'll say self.next is equal to none, just for now, because we've created a node that is all by itself. It doesn't actually currently have a next node. Now, the next class we're going to create is our linked list class. So this is where we're going to include all our methods. We'll say class linked list, and we can start with our initialization function. We'll say def init self, and we'll only have it so that you just create a blank linked list. And inside here, you're going to set your length equal to 0, self.length equals 0. And then we're also going to add a head node to this linked list. We'll say self.head is equal to a node with no value. So we have this length here just to keep track of the number of items in our linked list, and we're just keeping this head here because it'll be much easier to actually search through our linked list and remove things or append things or insert wherever we need to, or just get an item in general. Now, before we add any of the main methods, we're also going to add a helper method where we're going to call it getNode. So this just gives us the node at any particular index. And this is going to be really useful if we're trying to insert or remove or just generally get an item at a particular index, because it's all the same process of actually moving our traversing head into that direction. So we'll call this function getNode, so def underscore getNode, and we'll have index as a parameter because we just want the node at that particular index. And inside here, we're going to do a little bit of traversion. So we'll say trav is equal to self.head, and we want to keep changing our trav so that it's going to be the next item, so that we keep doing that until we get to the index that we want. So we'll say for blank in range index plus 1, we'll say trav is equal to trav.next. And we're saying index plus 1 because let's say we're starting at, let's say index is 0. Well, in that case, if I go only till for blank in range 0, that means I'm not going to do any iterations. So I'm going to end up with the head node itself, which is actually just a null node. All it is pointing to the very first item. So we're just shifting by 1, just so then we can actually access our items correctly. So we'll say for blank in range index plus 1, trav is equal to trav.next. That's basically just shifting over the current variable that we're using, the current item in our list that we're using. And we're going to keep shifting it over until we get to the index plus 1th item, which is technically item index. And then we'll just return this item. So return trav. So this function is going to help us code out everything else. So let's start with the get function. It's very straightforward. We can just say def get self and index. And most of the stuff is actually already done by the get node function. So we just have to check one condition, and that is if index is less than 0 or index is greater than or equal to self.length. Because if that's the case, that means we're trying to access an element that doesn't exist in our linked list. And if this is the case, we can just return nothing. Now, otherwise, we're going to return the item at this index. And getNode already does this, so we'll just say return self dot underscore getNode at index. And we want the value of this, so dot val. Because getNode returns the actual node object, but that node object has a value, and we want the value. So that's what we're returning here. So that's the get function. Let's do the append function now. Again, the append function is mostly taken care of. So we'll say def append self and val. Now, as we saw earlier when we were just writing the stuff out, we want to get the very last node, because that very last node, we can set its next node to a completely new node that has our new value. So in order to get that last node, we need to run self.underscore getNode with an index of self.length minus 1. So let's just call our variable prev node, and we'll set this equal to self.underscore getNode at index self.length minus 1, the very last node. And once we have this node is not going to have any next value, and so we're going to assign it its next node. So we'll say prev node.next equal to a new node with a value. And that's all we have to do. We just have to also increment our length, because now we have one more item. And that's all we have to do for append. Now it gets a little more tricky with the insert function. So with the insert function, we can say def insert self index val. So we want to insert value at some particular index. So with this insert function, we saw how we had to go to the node that was just one previous to the node that we want to insert at. And we need to set that previous node, its next node, equal to our new node. And that new node's next node equal to the previous node at that location. And so the first thing we have to do is make sure our index is actually valid. So if index is less than 0, return. Now, if index is greater than or equal to the length of our list, then we can just append it. So we'll say if index is greater than or equal to self.length, we'll say self.append val. And then we'll just return because our length already increases within this append function itself. We just say self.length here. Now, if this is not the case, then we need to find that previous node. So we'll say prev node is equal to self._get node. And then the index we're going to use is the index that we were provided minus 1, because that's the index of the previous node. And once we have this, we can say that we create a new node. So new node is equal to node with a value. And we set that new node's next. So new node.next is equal to whatever prev node.next is. And once we have that, we can now get rid of the connection between prev node and prev node.next. And we can instead have that connection between prev node and new node. So we'll say prev node.next is equal to new node. And then we can just increment the length, self.length plus equals 1. Now we can move to our remove function. So here we can say def remove, and we want to remove at a particular index. And it's very similar to the insert function. So first we have to just check our conditions, make sure that we have a valid index that we're removing. If index is less than 0 or index is greater than or equal to self.length, that means we don't have a valid index, so we have to return none. And we're not going to change the length. Otherwise, we can do the process that we need to remove the node and reduce the length by 1 and then return that removed item. So here, we're going to again use a prev node. We'll say prev node is equal to the previous node from that particular index that we were given. So self._get node at index minus 1. And then we will get the removed item. So we'll say removed is equal to prev node.next, since that's the element that we're removing. And then we're going to essentially remove this item by just removing any references to it. So we'll say prev node.next. Now this is currently set equal to the removed item, but we'll update this so that prev node.next is equal to whatever it was before, so prev node.next, but the next item of that one, so .next. So it's essentially rechaining your next node so that it's now set to something else. And that effectively gets rid of all the references to prev node.next. And finally, we can just decrement the length, self.length minus equals 1, and then we'll just return the removed item. Now the final function that we can implement here is just a simple iteration. And for this, we'll just return a generator object. You could, of course, use the iterable class and the iterable functions like the iter function and the next function, but we're just going to keep it simple. So we'll just say def iter self, and in here we'll say trav is equal to self.head, and for every item, so for I in range self.length, we want to first move the trav to the next one because we're anyway starting at the head, which is a null node. So trav is equal to trav.next, and then we want to yield that item. So when I say yield, we want to use this yield keyword here, and that allows us to give back a value temporarily to the user in the form of some sort of generator object. So we'll keep generating new values as we keep iterating. So yield trav.val. All right, so those are all the functions that we have to do here. Let's go ahead and test this out. So I'm going to create a new linked list. LST is equal to linked list. And now I can just print what it looks like. It'll be empty, of course, but I'll say print, and then I'll just separate by a space, .join map string list.iter. So this is just basically going through every item in my generator object, converting it to a string with the map object, and then joining it all together with a space as my separator. And the reason I'm using this map function rather than just writing join list.iter is because this list might contain data that are not strings, and this join function only works on data that are strings. So we'll just print this. Of course, it'll be empty. Now let's add some stuff. So list.append 1, And we can print this once again just to see what it looks like. And then we'll say list.append 3 maybe, and we'll add this down here. And we'll append a few more things, list.append 5, and we'll put this down here again just to print what we have. And now let's also insert something. So let's say list.insert. At index 2, we want 4. And then we'll just write this down here. And now maybe we want to test out our get function. So we'll say print got, and then list.get 0, since we should have that, and then 1, 2, 3, so I'll just put 1, 2, and 3. And these should print all the items that we have. And nothing else should work. I shouldn't be able to print a list.get 4. So if I print got and then list.get 4, I should get a none, and we'll see how that works when we run this. Now let's say I want to remove something. I'll say print removed index 1, because I'm going to remove at index 1, and then I will remove, so list.remove 1. This is going to return the node object itself, and I want the value of that, so .val. And so we'll print the value of the removed object, and we'll see that it's no longer there. So if we just duplicate this line and move it all the way to the bottom, we will see that the 1 is no longer there. And then maybe we can remove at index 0. So we could say print removed index 0 and list.remove 0.val. And then we'll run this again, and we'll see the final output for our linked list. So now we're going to go ahead and test this data that we have. But before I do that, I'm just going to include a colon here because I forgot to do that before. Make sure that you include that colon because you need those for loops. So I'll save this and I can run it. And I'll see that I get 1 and then 1, 3, 1, 3, 5, 1, 3, 4, 5. So here I inserted a 4 at index 2. So that shifted the 5 to the right and I could put a 4 there. And then I just printed all the items that I had. So I printed at index 0, that was a 1. I printed at index 1, that was a 3. And then at index 2, it was a 4. And at index 3, it was a 5. But then I tried printing index 4, and that didn't exist, so it got none. Now I tried removing index 1, and at index 1, I have a 3. So I removed that, and I can see that my updated linked list does not have a 3 anymore. And then I can remove at index 0, and now that returns a 1, so my new linked list doesn't have a 1 anymore, and I only have 4 and 5. So that's it for this video, and I hope this was helpful.